At this point, you guys should have already watched an introduction video to two-step equations, and you also should have watched a video with step-by-step instructions on how to do these multi-step equations. So what I actually want to do for this video is I want to go through the notes, but I want to do it not quickly, but I'm not going to take quite as much time as I did with all of the other videos to go through these problems with you. So remember that the key with two-step equations is that you're going to continue to follow the same steps where you're going to start with what you're given, take the units, bring them down in diagonal, but instead of putting the units that you're looking for in the numerator, you're going to use this mole map and you're going to figure out a plan. So in this particular problem, the example problem here, you were given 3.27 times 10 to the 24th atoms, and it asks you for the mass. So we were going from atoms to grams. So that's why, if you guys notice in this problem, they started with atoms, they brought that down in diagonal. The next unit in the numerator is moles, because that's where the next stop is on the mole map. They brought that down in diagonal. And then the last one is grams. Atoms to moles to grams. The units on the bottom, atoms were brought down in diagonal, and then moles were brought down in diagonal. So we're going to go ahead and do the first practice problem. It wants to know how many atoms are in 30.6 grams of calcium. So step one is going to be to start with what we're given. We're going to start with the 30.6 grams of calcium. Now remember that our second step, before we plug in numbers, do not plug in numbers yet, is we're going to take the unit and the substance and bring that down in diagonal. So we're going to put grams of calcium down at the bottom. Now in this map up here, we were given grams and we're trying to get to atoms. So we're going to have to go from grams to moles up to atoms. So that means that as we're writing this out, the next step in the numerator is going to be moles of calcium on top. We're going to repeat that step again. And just like we did originally where we had grams of calcium and brought it down, we have moles of calcium. And we're going to bring that down in diagonal. And then now we can finally put what we're looking for, which is atoms of calcium on top. So once again, start with what you're given. You need to go through wherever there's a conversion factor on these arrows to get to what you're looking for. So we went from grams to moles to atoms. So if you notice here, we went from grams to moles to atoms. Grams was brought down, moles was brought down. Now, the last thing we do is we need numbers. We have to have conversion factors. So anytime we see moles and grams together, we look right here. Between moles and grams, we're going to use that 1 mole is equal to the molar mass. So when we plug in these numbers, remember the number 1 goes with mole, and the molar mass of calcium comes from the periodic table, which is 40.08 grams. For the second conversion factor, we want to look for moles and atoms. So if you look up here, between moles and atoms, we're going to use that 1 mole is equal to 6.02 times 10 to the 23rd particles. So again, the number 1 goes with the unit mole, and then 6.02 times 10 to the 23rd atoms. Now, once we have all that and we go to plug this into our calculator, remember that we're going to multiply everything that's on top, everything that's in the numerator. So we're going to do 30.6 times 6.02 times 10 to the 23rd. And then we divide by anything on the bottom, which is 40.08. So our final answer always should have 3 parts. First is going to be the number, which is 4.60 times 10 to the 23rd. And then our units are always going to be whatever in the upper right-hand fraction. or it's what we're looking for, which is atoms of calcium. All right, the second problem, it wants to know what is the volume of 2.56 grams of oxygen gas. Now it gives us a hint here. Think about how oxygen exists in the air. Don't forget about Hoberfinkel. When we're talking about oxygen gas is diatomic, it's O2. So keep that in mind as we're writing this out. So once again, we're going to start with what we're given, which is 2.56 grams of O2, because this is a diatomic molecule. Then we're going to go ahead and follow our steps again. So over here, the unit in substance is grams of oxygen. So we're going to bring down grams of oxygen. Now we started at grams. What we're looking for is volume. We can't go directly to volume because we don't have a conversion factor. So we're going to have to go from grams to moles to liters. So that means that the next unit we're going to put on top is going to be moles of O2, because that's what comes next in the mole map. Now we're going to repeat steps 2 and 3, where we take whatever unit was in the numerator, put that in the denominator of the next fraction, and then up here we started with grams, we converted to moles. Now we can convert to liters, because ultimately that's what we're looking for. We can put liters of O2 on top. Then we go through and we plug in our conversion factors. So when we're looking at moles and grams, the conversion with moles and grams is that 1 mole is the molar mass. So 1 goes with mole, and then grams of O2 is 32. Remember, oxygen has a molar mass of 16, but since it's O2, it's 32. Then over here with moles and liters, when you have moles in liters, we use that 1 mole is equal to 22.4 liters. So we're going to put that 1 mole is 22.4 liters. Once again, we're going to multiply the numbers that are on top. We are going to divide by whatever's on the bottom, and we're going to get a final answer of 1.79 liters of O2. Okay, last but not least, this one wants to know what is the mass of 2.34 times 10 to the 23rd atoms of copper. So here we go again. Start with what you're given. 2.34 times 10 to the 23rd atoms of copper. Our second step is going to be to take whatever units and substance are here, bring them down in diagonal. So we are going to put now atoms of copper on the bottom. Now we need to double check our mole map. We're going from atoms to mass, which is grams. So up here, atoms to mass, which is grams. There's no direct conversion factor right here. So that means we're going to have to go from atoms to moles, then to grams. So if we have to go from atoms to moles first, that's what we're going to put in the numerator of the next fraction. And then we repeat our steps. Whatever unit is up here, we bring that down in diagonal. Moles of copper. Now, once again, we went from atoms to moles, then to grams. Atoms to moles to grams. So we're going to put grams of copper on the top. Now we need to go through and double check our conversion factors. So anytime we have moles and atoms, Anytime we have moles and atoms, we use that 1 mole is 6.02 times 10 to the 23rd. Remember that the number 1 goes with mole. The 6.02 times 10 to the 23rd goes with atoms, or molecules, formula units, particles. In this last conversion, we have moles and grams. So we double check moles and grams. We're going to use that 1 mole as the molar mass. 1 mole is the molar mass, which again is found on the periodic table. The molar mass of copper to 2 decimal places is 63.55 grams of copper. We are going to multiply everything on the top, divide by everything on the bottom, and we're going to get a final answer of 24.70 grams of copper. All right, as I've reminded you in all the other videos, make sure that you guys are following the steps and you're really paying attention to the details. Don't guess what numbers go there. Make sure that you are always using this map. There is no guessing with these problems. You don't need to guess. Follow the path, do your units first, plug in your numbers second. If you feel like you're setting up these problems right, you know you're setting them up, you have the units correct, the numbers correct, and you're still getting the wrong answers, you need to make sure you come talk to me about your calculator so that we can get that figured out. Go ahead and work on your homework. Remember that homework answers are uploaded to Canvas, so you can check those as you go.